Hi guys, okay, grade 9 math, another lesson for another day. We are on the third ratio. We are on the cosine ratio. Again, this shouldn't take long. You should be kind of figuring things out in terms of sine, cosine, and tangent right now. So cosine is adjacent over hypotenuse. Everything is going to work the same as it does for your sine and for your tan, just a different button looking at different sides on the triangle. I do want to clarify, anytime I put the word arc in front, arc sine, arc tan, arc cos, any of those, that just means that you're going to hit that second function button and then your sine, or your second function and then tan, or second function and then cos. I had a couple of people asking questions about that, so I just wanted to clarify that. So other than that, everything really is going to be very, very, very similar as it is with sine and with cos. It's just that you will know different sides this time. So I have the textbook. So again, if they want you to find cos of 42 degrees, it really is as simple as hitting cos 42 on your calculator, and you should get 0.743. So cos of the angle, you don't need to hit the second function button, you just hit cos and then the angle. If, though, you are trying to find the angle, that's when you have to hit that shift or that arc cos. So for example, number 2 on page 242 gives you a triangle, and they label it B, D, and E. I don't know where C went. And they tell you that this is 5 and this is 13, and they want to know what is cos B and then what is actually angle B. So B is your reference angle, just grabbing Harriet. So cos B means they just want to know the ratio. So cos is the adjacent side over the hypotenuse side. So for B, the adjacent side is 5, the hypotenuse side is 13. If you're confused about which one is the adjacent and which one is the hypotenuse, remember the hypotenuse is always the longest side, and it's always the one directly across from your right angle. That is always your hypotenuse. Some people get those two mixed up. So now if we want to find angle B, this cos needs to come over here. So what is that arc cos? It's that cos with a little exponent of -1. Again, when I use the term arc cos, that means you're going to hit, for me, it's the yellow second function button on my calculator. It's slightly different for everybody's, but it should be up in this corner somewhere. So I'm going to hit shift cos of 5 over 13. And if I do that, I'm so thankful that calculators will do fractions. 5 over 13 is 67 degrees. Whenever we give an angle, we usually give the angle to the nearest degrees. We usually don't put decimals in an angle. When we figure out sides, usually we round that to the nearest tenth if we need to, but angles is usually to the nearest degree, so no decimals in angle. I am sorry about the barking dog. I don't know what is bothering her. All right, just a second. I'm going to pause the video while I tell the dogs to shut up. Okay, I'm back. So sorry about that. Not that it felt like any time to you, it just did to me. All right, so that's example number 2. Example number 3. Example number 3 says, it gives you a triangle, and it orients it a little differently. It puts the right angle up in that corner. And they have W, X, and Y. And then they have, oh, you can hear my dogs, I'm sorry. 11, and 24. Now, they want to know xy. They want to know this right here, which we're going to call little w. I talked about that before, the fact that the angle is the capital letter, the side across from it is the little letter. You could also call it xy if you want to, but I don't want to write two letters. I'm lazy. I'm going to write one. I'm going to write w. So what we want to, there's a little dog fight happening at my feet. Wicket. Just a sec. Get. Sorry, there's a dog fight at my feet. Hey, it's nothing if not entertaining. All right, so we have to find this side. This is not as straightforward. This is not going to happen in one step. You're going to need a couple of steps to do this. And it can be a couple of different steps depending on how you choose to do it. I'm going to do it a couple of different ways so that you can see how there's more than one way to do this. I haven't looked in the textbook really. I'm not sure how they do it. I'm going to do it at least two different ways so you can see that there are options here. So one of the first things I could do is, actually I could do this all in one step if I wanted to, if I have a really good handle on sine, cosine, and tangent. I could recognize, well actually no, I could just use Pythagorean theorem. You can tell I'm thinking this through just as I go, right? I could actually just use Pythagorean theorem to solve this, which is probably how I would do it. Because I know two sides, I want to know the third. I really remember that this has to be my C because it's my hypotenuse, but the other two, it doesn't matter. So I could do w squared plus 11 squared is 24 squared. And so I could do w squared plus 121 is equal to 576. So I would subtract 121 to both sides. And so minus 121. I get that w squared is 455. So I'm going to take the square root of both sides. And I'm going to get that it is 21.3. So there's my answer, 21.3. I didn't need to use SOHCAHTOA at all. However, I could have. What I could have done is I could have said, listen, I know my adjacent side to W, and I know my hypotenuse side to W. And so if I know my adjacent and my hypotenuse, that's cos, I can actually figure out what this angle is. And so I could do cos of angle W is the adjacent side, which is 11, over the hypotenuse side, which is 24. Now, if I move this cos over here, remember it becomes that arc cos thing. So I would have to hit my second function button. So second function cos of 11 over 24 would be 63 degrees. So I would get that this angle is 63 degrees. Now that I know that that angle is 63 degrees, I could say that's the opposite side that I want to know. This is the hypotenuse side, and I know what it is. And sine is opposite over hypotenuse. So I could potentially say sine of, not of W now, because I know the angle now, because I figured it out up here. I could say that sine of 63 is the opposite side, which is what I want to know, over the hypotenuse side, which is 24. Now I want to get the W by itself, so I'm going to multiply this side by 24. So I'm going to multiply this side by 24. And so in my calculator, I'm going to put 24 times sine of 63. So 24 times sine of 63 gives me 21.3, which is the same answer I got when I did Pythagorean's theorem. I would rather do this. It's one step instead of 2 or 3, less chance of error. But because this is the cosine section, that's why they show you this method. I would never, if I was just told to find W, I would never do this. I would do this. I'm not fussy as long as you show your work, show your work, show your work, show your work, so that I know what it was you did. I don't care which way you choose to do it. All right, just please, again, make sure you show your work. Because if you got it right and all the way to here, but then you hit a wrong button when you did the square root of 455 and you got the wrong answer here, again, I don't have to take off very many points if that's what happens, versus if you just don't know what you're doing. All right, I think one more example, and that's it. The lesson will be done for the day. By the way, you guys are probably the best class at getting your work done right away and uploaded to me first thing so that it's all done and over with and you can go and do whatever you want. Youngest of the classes I teach, but probably the best one in terms of getting stuff done. So, example number 4 says you have a ladder and it's leaning against a wall. So here's the wall, here's the ground, there's the ladder, all right? So it's leaning against the wall and it makes an angle of 65 degrees with the ground. So here's the wall, here's the ground, here's the ladder. And it says the ladder makes an angle of 65 degrees with the ground. So between the ladder and the ground. You have to make sure that you get the information in the right places or you will end up with a wrong answer. The foot of the ladder, so the bottom of the ladder is 2 meters from the base of the wall. So the bottom of the ladder, the bottom of the wall, they are 2 meters apart. So 2 goes there. Again, really important that you get the diagram right. If you have to read the question 2 or 3 times, do it. Again, notice my strategy is I just take a piece and I figure out what is that piece saying, where do I put that piece. So now it says calculate the length of the ladder. So that's the ladder. So this is what I want to know. I want to know the length of the ladder. Several times I will see people get a question like this and they'll actually find this, which would be the height of the wall. That's not what I'm looking for. I'm looking for the length of the ladder, and the ladder is the thing that's leaning, so that's what I'm looking for. So my right angle is here because that's the ground, that's the wall. Hopefully they are at right angles to one another, otherwise you have a crooked wall or a crooked floor, and if that's the inside of your house, that's bad. So calculate it to the nearest tenth. So for this question, I don't think that the math is the particularly hard part. I actually think the harder part is getting the diagram right. That is more often where I would see the mistake. It's not usually in the math. So here, I know the adjacent side to the angle, and I want to know the hypotenuse side. So adjacent and hypotenuse means I'm doing cos. So cos of 65 is the adjacent side, which is 2, over the hypotenuse side, which is what I'm trying to figure out. So again, if your variable is in the denominator, the only thing I can do is get rid of it. So I have x times cos of 65 is 2. So I'm going to divide this side by cos of 65. So I'm going to divide this side by cos of 65. No need to hit your second function button, even though I've moved my cos from one side of the equal sign to the other, because I've moved the cos and the angle. I've moved that whole statement. So I don't need to do the arc cos. I just need to do, because I could have at the beginning when I had cos of 65, I could have put that in my calculator and put a decimal number there. The only thing is I would be rounding off. So I'm going to go to my calculator and I'm going to put exactly what's there. I'm going to do 2 divided by cos of 65. So 2 divided by cos of 65. And I get, they said round to the nearest tenth, so that is 4.7. So the ladder is 4.7 meters. That's the end of this lesson. I think, let me turn the page. Yep, that's the end of this lesson. So we really only have one more section to go in this. I'm still trying to decide exactly how I want to evaluate this. It might be just something I send home, give you a couple of days to do, and you send it back. It's probably the easiest thing to do, so it's probably what I'm going to do. But we'll discuss that when we get there. The last section is going to take probably a couple of days because there's more work to it. And so I'll probably do a video and then give you a couple of days to work on it and ask questions because I anticipate more questions with that last section. There usually is. So this lesson that I'm recording now should be for Thursday. So probably Friday and Monday at least will be the last section. And then we can talk about maybe sending you an assignment to do. All right, thanks, bye.